Section 2.9, solving one-step inequalities by adding and subtracting. We have done this with equations, and now we're going to do it with inequalities. So here's the subtraction property of inequalities, which means subtracting the same value from each side of an inequality does not change the answer. The arithmetic version is if I have a sample of 9 greater than 7, then I can subtract 2 on both sides, and that inequality does not change. 9 minus 2 is 7, 7 minus 2 is 5. 9 is greater than 5. Also, if I have 4 is less than 7, and if I subtract 2 from both sides, it doesn't change the inequality. The algebra version is if I have a and b, which are both real numbers, and I subtract something from both sides, the inequality still holds. And the same if I have a is less than b, two real numbers, and I subtract c from both sides, the inequality still holds. And the same is true for the addition property of inequalities. Adding the same value to each side of the inequality does not change the inequality. The arithmetic version is 9 greater than 7. So if I add 2 to both sides, the inequality holds. 4 less than 7, and if I add the same quantity to both sides, the inequality still holds. The same for the algebra version. A is greater than b, and if I add the same quantity to both sides, the inequality holds. And a less than b, two real numbers, adding the same quantity to both sides, the inequality still holds. Here's our procedure to solving inequalities. 1, I want to copy the problem. 2, I want to use inverse operation to solve the problem. Therefore, if something's being added to my variable, I want to subtract on both sides. If something is being subtracted from or a negative added to, I want to add that to both sides. And when I'm done, I have the solution in inequality form. I want to then graph the solution set if told. Let's take a look at a couple of examples. Solve each inequality, and then I want to graph the solution. Number 1, I want to copy the problem. F plus 12 is less than a negative 7. So if you have that in your book, please copy it. Remember, from the rules for solving equations in this fashion, I want to start on the variable side. And that means I'm on the left side of my inequality. What's happening to my variable? Something's being added to it. Therefore, I need to subtract that value from both sides. And that gives me F is less than a negative 7 minus 12. Same sign combined, use the sign, a negative 19. My solution is F is less than a negative 19. I want to graph that solution. Negative 19, negative 18, negative 17, and to the left, negative 20, and a negative 21. My inequality is a less than symbol. Therefore, that is going to be a starting point that is an open point. It's not shaded. And I want to graph all solutions to the left or less than a negative 19. Number 2, a negative 15 is greater than and equal to a negative 8 plus p. Copy the problem. And now I want to start on the right side of my inequality because that's where my variable is. And what is happening to my variable? Something is being added to it, but that is a negative 8. The inverse of the negative 8 is a positive 8. So I'm going to add 8 to both sides. On the left-hand side, I have a negative 15 plus 8. Different signs I want to subtract. 15 minus 8 is going to give me 7. 15 is greater than 8, and 15 is negative, so I have a negative 7. And I have the greater than or equal to symbol. I just bring that symbol down. And I have the 8s that cancel each other, and that leaves me with p. And I read that as p is less than or equal to a negative 7. And I graph that. Negative 7, negative 6, negative 5, negative 8, negative 9. Greater than or equal to, so that is a closed point. And p is less than a negative 7, so I will shade to the left. Next, I want to solve each inequality. Again, graph the solution. Number 3, z minus 5 is greater than a negative 14. I start on the left side of my inequality. We copy the problem. What's happening to z is something's being subtracted from it, so I'm going to do the inverse, which is add 5. That gives me z. Bring down the inequality. And a negative and a positive, different sign, subtract. 14 minus 5 is 9. 14 is greater than 5, and 14 is negative, so my solution is negative. And I graph negative 9, negative 8, negative 7, 10, negative 11, and I have a greater than symbol, and that means that I'm going to have an open point at negative 9. Z is greater, and I shade to the right. And number 4, 13 is less than or equal to k minus 9, or k minus 9 is greater than or equal to 13. I start on the right side of my inequality after I copy the problem. What's happening to my variable is something is being subtracted from it, so I'm going to do the inverse, which is add that number to both sides. And that gives me on the left-hand side, same sign combined, 22. Less than or equal to symbol comes down, and the 9's cancel, negative and a positive 9 go to 0, leaving me with k is greater than or equal to 22. And I want to graph the solution. And my starting point with an inequality symbol of greater than or equal to is going to be a closed point, which means I shade that point. K is greater than or equal to a negative 22, so I shade to the right.